Number 6. Limits. We did do some limits. And we did the limits mainly, well, we did one above there, but this one falls into the category of which rule. What have I got on top? What have I got on the bottom? I guess there's, well, no, okay. What have I got? 0 over 0? What does that kick in then? The top goes to 0. The bottom goes to 0. So I'm going to use L'Hopital. L'Hopital it. 0 over 0, infinity over infinity. Okay, so let's see. 5 square root of 5x plus 25, that's 5x plus 25 to the 1/2, so the derivative would be 1/2. 5x plus 25 to the negative 1/2 times what? Derivative of the inside, which is 5. The derivative of negative 5 is 0. So that's the top derivative, and that's L'Hopital. L'Hopital says do the derivative of the top, derivative of the bottom, then do the limit of that. What's the derivative of the bottom? 1? Okay, well, rearranging a bit here, wouldn't this be, since the bottom is 1, wouldn't this be the limit as x, let's move over here, got plenty of room, so wouldn't that be the limit as x goes to 0 of, I believe the top's just going to have 5, and then the bottom is going to have 2 square root of 5x plus 25. I think I can do that limit. As x goes to 0, I can plug that in, can't I? X is 0, so that would go to 5 over 2 square root of 25, which is 5. 2 times 5, which is 5 over 10, or 1/2. Yeah, so we can use L'Hopital, 0 over 0, infinity over infinity. We've done several of those along the way. But number 7 is another matter. Yeah, lots of different indeterminate forms. What form do I have here? X is going to 1 on the positive side. Well, the bottom on number 7, part of it anyway, what does this one go to right here as x goes to 1? Positive side. Well, 1's going to be an asymptote, so think of it that way if you look at the graph. That's going to go to infinity, isn't it? And then we looked at, the log, natural log is x goes to 1 goes to 0, and 1 divided by something going to 0 is also infinity. So I've got infinity minus infinity. Is that 0? I wouldn't recommend saying that's 0. It might be, but you got to work it all out. What do we need to do here? Well, one of the tricks that we did for infinity minus infinity was combine this into one, if you've got fractions, combine it into one fraction, which would just mean multiply this one by ln of x, right? And then the 1 over ln of x, multiply it by the x minus 1, top and bottom. Which gets me limit as x approaches 1 from the right of ln of x minus x minus 1 over, now I have a common denominator so I can combine them, right? So now what do I have? Well, now I have a L'Hopital, don't I? The natural log of 1 goes to 0, and then if I plug in 1 here, that goes to 0, so the top goes to 0. The bottom, that would be 0. That would be 0, so the bottom is 0. So I've got a L'Hopital. I can L'Hopital this. What does L'Hopital give me? If I do that for this one. Well, L'Hopital says do the derivative of the top. Derivative of the top, we got ln of x, derivative of it's 1 over x. Minus x minus 1, won't that be minus 1? And then the derivative of the bottom, well, guess I could do it a couple ways, but it's a product rule. One thing it is. First times the derivative of the second, which would be 1 over x, plus the second times the derivative of the first, which is 1. Which unfortunately gives me what? 0 over 0 again, doesn't it? If x goes to 1, wouldn't the top go to 0? The bottom goes to 0 as well, because you have 0 plus 0. What do? L'Hopital again. Multiple L'Hopitals here. Now, what I would, well, before I L'Hopital it, let me do this. Let me rewrite this a little bit. Why does that sometimes? Okay. All right. So a L'Hopital, wait for a L'Hopital. Let's make this as x to minus 1 minus 1. And then if I distribute this in, I get what? 1 minus x to minus 1. That'll just make it easier to do the derivative. Now let's L'Hopital. So that's going to be, the top derivative would be what? Be negative 1 x to the minus 2 minus 0, so it's just that. 0, that would be minus, then we have minus 1 times x to the minus 2, and then 1 over x, right? Well, it looks pretty bad, but if I plug in my 1 now, can't I? If I plug in 1 now, don't I get negative 1 on the top? This and this make a positive, so that would be a positive 1 plus a positive 1. That's negative 1/2. Right?
Is it legal to multiply x on both sides before you do that?
Top and bottom, multiply by x on both bottoms? Yes, yes, sure could. Yeah, that would be another alternative. Multiply top and bottom by x there, sure. Lots of different ways we could do that one. Is that okay? Okay. Number 8. Lengths of curves. We did arc lengths. Remember its formula? Vaguely? Well, the arc length was what? Anybody remember? Anybody have a note card with it? This might be a formula you might want to, because you will get a note card on this one too. Huh? 5 note cards? Try to keep it down to 1. All right, what'd you say? L equals arc length.
The integral of a to b square root of 1 plus f prime of x squared.
Okay. F prime or dy dx squared, yeah. Yeah. All right, so what do we got here? In this case, L will be square root a to b. Well, I've got square root first, do the integral first. So it'd be integral a to b, that's my 1 to 9, right? Square root of 1 plus, yeah, do the derivative of this guy. Derivative of that would be 1/3 times 3/2 x to the 1/2 minus 1/2 x to the minus 1/2. Or 1/2 x to the 1/2 minus 1/2 x to the minus 1/2. But don't forget you got to square that. Ooh. See if I have enough room there. I'm writing too big. Yeah, you got to square that. So you got to square the derivative. 1 plus the derivative squared. Well, this one, remember what happens? Well, if I square, see if I can, yeah. If I square this out, write it out twice or whatever, here's what I get. I get 1/4 and 1/2 times 1/2. X to 1/2 times x to 1/2 is x. And then the middle term is going to be what I've got? 1/4 times minus, 1/2 times minus half minus 1/4. X, well, the x to the half, x to the minus half cancel out, so let's just do this. It's minus 1/4. And then the other two would be also minus 1/4. And then minus 1/2 x to minus half times minus 1/2 x minus 1/2 is plus 1/4 x to the minus 1. Well, altogether there, we're going to get integral 1 to 9 of 1/4 x. The 1, the minus 1/4, and the minus 1/4 gives me a positive 1/2 plus a 1/4 x to the minus 1. Yeah, that turns into another perfect square. Turns out it's 1/2, again, x to the 1/2 plus 1/2 x to the minus 1/2 squared. It's usually how those funky looking ones for these come out, what they come out looking like. And that's good because the square root squared, those all cancel out. So it's just the integral 1 to 9 of 1/2 x to the half plus 1/2 x to the minus 1/2. So now we can just do power rule. What do I get? 1/2 will be x to the 3/2, so it'll be 2/3. X to the 3/2 plus 1/2 x to the half, so it'll be 2 over 1. That's good. The 2's cancel from 1 to 9. So I wind up with 1/3, 9 to the 3/2 plus 9 to the 1/2 minus the 1's. So it'd be 1/3 plus 1. So whatever that lovely 3, 27, 9. Okay, so I can do this by hand. 9 plus 3 minus 1/3 minus 1. 4 2/3. I do believe. Did I do that right? No. 7 2. Where did I get 4 2/3? I don't know where I got. That's 12, 11. Be 11 minus 1/3. 10 2/3. Or 32 over 3. Is that what you got? Okay. Now I'm happy. All right, well, that kind of flows into number 9 there. What page are we on? Page 3, okay. Just have 5 pages of this. All right, number 9. Find the area of the surface of revolution generated by revolving the curve about the x-axis. Well, that's also a little formula. Call it A, call it S, whatever you want to call it. What is the formula there? A to B. Two pi f of x 1 plus the arc length. Yeah. Take 2 times f of x times the square root of 1 plus f prime of x squared dx. Okay. All right. So this is going to be, see what happens. How much room we got? All right. So it's going to be 1 to 5. 2 pi f of x is square root of x plus 1. Square root of 1 plus, well, the derivative is what? 1/2 x plus 1 to the minus a half? Or 1 over the 2 squared of x plus 1? Do that squared. And notice again that square root part, that's the arc length. So you just take the function times the arc length times 2 pi. Well, let's see what happens there. Usually some nice things do happen, which I think they do here. It's going to be the square root of 1 plus 1 over 4 x plus 1, because the square root squared is just going to leave the inside part. What do I do next? What do you want to do next? Well, probably on that square root, second one, get a common denominator. So that would give me the common denominator of 4, would put that as what? 4x plus 4 plus 1 over 4 times x plus 1. I'll leave it like that. Because then I'm going to take the square root of the bottom there, square root of the bottom and the top. So the top would be the square root of 4x plus 5. The bottom would be 2 square root of x plus 1. The reason I'm going to do that is because that'll cancel out those nicely. So I'll wind up with, and the 2's cancel. So I'll wind up with the square root 1 to 5 of pi square root of 4x plus 5, which is just a little u substitution. D over 4. So it's going to be the integral of pi square root of u d over 4. So you get 1/4 or pi times 1/4 square root of u, antiderivative would be u to the 3/2. So it'll be 2/3 times u to the 3/2. But u, cancel the 2's out, so it'd be pi times 2/3. U is 4x plus 5. I think that's why the choice of 1 to 5. So pi times 2/3. Plug in a 5, we have, to the 3/2, sorry. We have 25 to the 3/2 minus 2/3. Plug in 1, we'll have 9 to the 3/2. Whatever that works out to be. Huh? Oh. Where did I get 2/3? Not 2/3, 1/6. Thank you. Yeah, 1/6. Just checking. So 1/6, 25 to the 3/2, which is going to be, what, 125? So it's 125 over 6. 9 to the 3/2 would be 27, so 27/6. That is 16 1/3, 49/3 pi. That's what I get. Anybody else get that? Believe that? Our area, surface area, 49/3 pi. You don't believe me on that one? Trust me? Okay. All right. All right. Only 2 more pages, or 1.5 pages. We'll be done. Huh? Where's another page? Huh? Where's yours? I go get them.